Now, after the discussion of amino acid, we are going to discuss polypeptides and proteins. So, when amino acids join together by amide bond means CONH bond. So, when amino acids are joined together by amide bonds, they form larger molecules. And these larger molecules are either called peptides or polypeptides or proteins. So proteins or polypeptides are formed after joining amino acids together with these amide linkages, amide bonds that you must remember. These amide bond or amide linkage, CONH bond, in polypeptide or protein is called peptide bond. So this bond is called CONH bond is called peptide bond. And this peptide bond is formed after the reaction between COH group of one amino acid and NH2 group of another amino acid, because both groups are present in a same molecule. So we must say that the COH group of one amino acid combines with NH2 group of another amino acid. Water molecule is eliminated to form this peptide bond. So this is peptide bond. You look here first. This peptide bond. Now this peptide bond is more stable. You can show here resonating structures for this peptide linkage. So to draw the resonance structure, we have to use this lone pair which is on nitrogen. It is moving in between this carbon and nitrogen, and this double bond, pi bond, is moving on oxygen as a lone pair. So you can see here there are three lone pairs on this oxygen because this pi bond is moved completely over oxygen, and there is double bond between carbon and nitrogen because this lone pair is shifted in between carbon and nitrogen to form a pi bond. So from these two resonating structures, it is clear that the CN bond in peptide linkage or peptide bond is not a completely single bond, or it is not a double bond. It is in between double and single, or you can say there is some double bond character of or between C and N. So this bond is having some double bond character. So because of this, the rotation, the free rotation which we can assume between this C and N, 360-degree rotation, if this bond is single bond, that rotation is restricted because of this double bond character. And if that rotation is restricted, we can have two conformations for this peptide bonds or peptide molecules. These two conformations I have shown here. One conformation, that means conformation means three-dimensional arrangement of atoms in a space. So this is called s-trans conformation, and this is called s-cis conformation. S-trans means what? Because of this partial double bond character, two R groups means side chains are lying toward the opposite side of the CN bond. And in s-cis, these R's are, you can see here, these bulkier groups are toward the same side of this CN bond. So when R are toward opposite side of the CN bond, we can say this is s-trans conformation. And when R are toward the same side of the double bond, carbon-nitrogen bond, then it is called s-cis conformation. Obviously, s-trans conformation is more stable because two bulkier groups, two bulkier side chains are lying toward the opposite sides, means they are far away from each other, so there is less interaction. So you always remember that s-trans arrangement is a stable arrangement. And now we'll move toward its structure. You can see here a carbon-oxygen double bond. This carbonyl group in amide is sp2 hybridized. You know that very well. And if it is sp2 hybridized, the geometry is trigonal planar. That means this molecule or this linkage or peptide bond is a planar bond. all 6 atoms 1, 2, 3, 4, 5 and 6 involved in this peptide bond are actually lying in a one plane. So this is a planar because of these two things. All 6 bonds, again one more thing, you can measure the bond angle because of sp2 hybridization. This bond angle, or you can see this bond angle, or this bond angle is of 120 degrees. So this is of 120 degrees. Another point which I want to add here, this CO bond and NH bonds are actually oriented 180 from each other. You can see they are as if on the one line, and one line means 180 degrees from each other. Okay, one more thing I must add here. If s-trans conformation is more stable, that means this molecule is always existing in that conformation, and because of this polypeptide or protein always having zigzag arrangement. So because of s-trans arrangement, the arrangement is zigzag. So yeah, this much information regarding the peptide bond is sufficient. Now we will discuss about polypeptides and proteins. When 2 amino acids join together by one amide bond, it is called dipeptide. And when 3 amino acids join together by 2 amide bonds, 2 CONH bond, then it is called tripeptide. I have given here the structure of dipeptide and tripeptide. You just watch these two structure very carefully, because you have to follow this pattern while drawing dipeptide, tripeptides or polypeptides. Now see, you remember we have just seen that the conformation, which conformation is more stable? S-trans conformation is more stable. That means while drawing dipeptide, tripeptide, tetrapeptides or so on, we have to keep all alkyl groups, all side chains are toward the opposite side. If one R is shown toward the above the plane, another R must go to the down the plane. Now see here how. In case of dipeptide, means 2 amino acids join together by using this one peptide linkage. This is one peptide linkage which is a planar, and you can see here all 6 bonds are actually lying in one plane. This middle portion, this is peptide bond, amide bond. Now you can see here R, you have to show this is, you can see here this is carbon, R is side chain. You can see here R is lying above the plane, and if R is lying above the plane, this H is now going behind the plane. That's why shown by using a broken wedge. Now this R will be there on the second amino acid, means this part. Now because of the trans arrangement, this is this chain is drawn in a zigzag manner. So this will go up and down. Now this C will go down, where the R will change its position. You can see here carefully. Here the R is lying above the plane, which is shown by solid wedge. Here the R of this amino acid portion is shown by using a broken wedge, that means lying behind the plane. So positions of R and R dash, means side chain of this dipeptide, are actually opposite to each other. That means this is S-trans conformation. Similarly, you can I have shown here a tripeptide which is formed after joining 3 amino acids. One amino acid here, one amino acid at the middle position, and another is at this terminal. Now you can see here there should be 3 R's of 3 amino acid. These are above the plane. Now R is coming here below the plane, broken wedge. Now this R is above the plane, means above the opposite to this. So you have to, while drawing this chain, you keep in mind that the R must go toward the opposite sides, because S-trans arrangement or S-trans conformation is more stable. So here one peptide linkage, one amide peptide bond, and this is another peptide bond. In tripeptide means after joining 3 amino acids. So polypeptides and proteins have many amino acids joined together that we have seen. The protein term, this term we have seen when to use polypeptide and when to use protein. This protein term is reserved for the polymers because they are formed after joining many amino acids which are having more than 40 amino acids. So if polymer is having more than 40 amino acids, it is better to use word protein and not polypeptide. And if the polymer having less than 40 amino acids, you can use the term polypeptide. I hope it is clear now. Amide bond in peptides and proteins in both are called peptide bonds. So these are peptide bonds. In fact, they are amide bonds. But in peptides, polypeptides and proteins, they are called peptide bonds. They are called peptide bonds. And the individual amino acids are called amino acid residues. You can see here the meaning of this line. In a dipeptide, this is actually one amino acid and this is another amino acid. So amino acid 1, amino acid 2. So this free portion of the amino acid is called amino acid residue. So this is amino acid residue of one amino acid and this is of another. Here this is amino acid residue. So you can write here the individual amino acids are called amino acids residues. The amino acid with the free amino group. Now you can see here this amino acid having NH2 group free and this amino acid having COOH group free. Then there are two terms which we can use. So for the amino acid where NH2 group is free is called N-terminal amino acid. So this is N-terminal amino acid, whatever it may be. And when the COH group is free in the amino acid residue, this is called C-terminal amino acid. So there are two types of amino acids present in a polypeptide or protein. N-terminal amino acid, that means having NH2 group free, and C-terminal amino acid means having this carboxy group free. Now N-terminal amino acid is always written toward the left end of the chain. So this is left end and this is right end. So while drawing the dipeptide, tripeptide or polypeptide, NH2 group, pre-NH2 group must lie toward the left hand side and COH group, carboxy group, we have to draw toward the right hand side. So N-terminal amino acid residue is always toward the left hand side and C-terminal amino acid is toward the right hand side. So that much primary information you must know regarding polypeptides and proteins, and this information you must utilize while drawing the structures of dipeptides, tripeptides or even polypeptides. Thank you.